All right, so lesson 3, we're talking about motion problems. If a body moves so that its velocity is proportional to the elapsed time, then we would say that v velocity would be equal to a times t, where a is a constant. We're asked to show that v squared is equal to 2as. And we learned before that velocity is the rate of change of distance with respect to time, or displacement with respect to time. So velocity is ds by dt. We're told above that v equals a times t. So we can say that instead of v equals ds by dt, then ds by dt equals a times t. So to find s, it would be the antiderivative of ds by dt. So s will equal, now we're told at the top that a is a constant, so the variable here is the letter t. That's what we're going to add the exponent to. So we're going to add 1 to the exponent on t that is there, which right now is 1, which will give us an exponent of 2, and we'll divide by that value, so we'll get 1/2 at squared, again, plus c. Can't forget about that arbitrary constant. Now, because c is the position function, the displacement function, when t is 0, s will always be 0, because it hasn't started to move. So when t equals 0, s will equal 0. So again, like we did yesterday, we've got some initial conditions. We can determine what our c value is. And so c will equal 0, because 0 squared is 0, times a is 0, times 1/2 is still 0. So you've got c equaling 0. And so now we can say that s equals 1/2 at squared. So what I'm going to do now, again, we want to show that v squared equals 2as, right? So to get a 2a in front of the s, I would multiply both sides by 2a, because I need to show, or we need to show, that v squared equals 2as. So we've already got the variable s on the left. If we multiply both sides by 2a, we'll have 2as on the left, and on the right side you'll have 2a times 1/2 at squared. So 2 times 1/2 is 1. A times a is a squared, so we're going to get a squared t squared. But remember that v equals a times t. So v squared would equal a squared t squared. So now we can say that 2as equals v squared, which is what we were asked to show. Okay, so there's that one done. Number 2 says a particle is accelerated. It travels in a straight line, so its velocity in meters per second is determined by v equals the root of t, where t is measured in seconds. Determine how far the particle travels in the first hour. So again, we have velocity, which remember is ds by dt. The derivative of the position function gives you velocity. It's the instantaneous rate of change over time. And this equals t to the power 1/2. So again, to find out what s is, we would take the antiderivative. So we would add 1 to the half. You're going to add 2 halves, which will give us 3 halves. And then we're also going to divide by 3 halves, which is the same as multiplying by 2/3. And then we have our constant on the end. And once again, this is now the position function. So once again, when t is 0, s will be 0. So therefore, c will be 0. we can go through the process of letting t equals 0. 0 to any power is 0 times 2/3 is 0. So again, c will equal 0. And our position function will be 2/3 t to the power 3/2. So in this case here, we are told that the formula in velocity is meters per second. So if we want to find out, if we want to find out how far it traveled in the first hour, then t would have to be the number of hours in, or the number of seconds, I should say, in an hour, because t is time in seconds. We want to know how far the particle traveled in the first hour. So the time will be the number of seconds in an hour. 60 seconds in a minute times 60 minutes in an hour. So that'll be 3,600. It'll be 2/3 times the square root of 3,600 cubed. So I've got 2/3 first times the square root of 3,600, and that is cubed. So 144,000 meters will be our answer. Again, the velocity is in meters per second, so our distant unit is meters, which we could convert that to kilometers by dividing by 1,000. 144 kilometers. Acceleration of a particle is defined by a equals 16 times t plus 2 to the negative 2 meters per second squared. Determine the velocity at any time if the velocity is 8 meters per second at time 0. Well, again, acceleration is the rate of change of velocity with respect to time. We learned that before. So a, which is the same as dv by dt, would equal 16 times t plus 2 to the negative 2. So to find v, the velocity, in terms of t, again, we would take the antiderivative. We would add 1 to the negative 2, which will give us negative 1. We'll also divide by that value, and also we divide by the derivative of what's inside the brackets, which in this case is just 1. And again, it's the general antiderivative, so there's that plus c on the end. So we will say that the velocity equals negative 16 over t plus 2 plus c. And in this case, we are told that the velocity is 8 at time 0. So this will allow us to determine what c is. Velocity is 8 at time 0. So 8 will equal negative 16 over 2 is negative 8 plus c. Add 8 to both sides. And c also equals 16. So our velocity at any time t could be found by going negative 16 over t plus 2 plus 16. You could add those two terms together by getting the common denominator of t plus 2, and that would allow you to write it as one rational expression. Not required, but it could be done. Number 4 says a stone is tossed upward from the edge of a 63-meter high cliff with an initial velocity of 8 meters per second. Determine how long it would take for the stone to hit the ground. So let's start by letting h equal the height, and that would be in meters. and t equal the time, which would be in seconds. Right? The cliff is 63 meters high. The initial velocity is 8 meters per second, so that tells us that our height will be in meters, our time will be in seconds. Now, we know that v, the velocity, is, we can say ds by dt, the displacement, rate of change of displacement over time, which would be the same thing as dh by dt in this case, because we're measuring the height of the stone. So that'll be dh by dt. Now, also, since gravity is acting on the stone, then dv by dt, the rate of change of velocity with respect to time, would be negative 9.8. Now, you might remember that from physics. It's not something that you would need to remember for this course. Okay, we're going to develop this equation because we weren't given an equation at the start, but we're going to see how it can be developed, but you wouldn't be tested on that. Right? Anything you'll be tested on will be like the previous questions where you're given that initial formula, initial relationship. Okay, so again, dv by dt is negative 9.8, and that would be t to the power 0, right? Because velocity with respect to time, because you have dt on the bottom, that tells us that the variable is t. And because dv by dt is a constant, we put it with the variable to the power 0. So now we can take the antiderivative. So v will be the antiderivative of that. It'll be negative 9.8 t to the 1 over 1 plus c, or negative 9.8 t plus c. So there's velocity. Now we are told that the initial velocity is 8 meters per second. The stone is thrown with an initial velocity of 8 meters per second. So v equals 8 when t equals 0. So this will allow us to determine what c is. So velocity will be 8 at time 0. Whoops, that's not 0 there, that's 1. But we're going to let the time be 0. And so c will equal 8. And we can write a velocity equation now. Our velocity in terms of t will be negative 9.8 t plus 8, which is the rate of change of displacement, or in this case height, with respect to time. So dh by dt will be negative 9.8 t plus 8. And that last term, we can write it as a function of t. It'll be times t to the power 0, because now we want to get our height function by taking the antiderivative of this. So it'll be negative 9.8 t squared over 2 plus 8t to the power 1 over 1 plus c. Or h equals negative 4.9 t squared plus 8t plus c. So you should recognize that negative 4.9. You would have seen that before whenever an object was thrown up and gravity's acting on it. We often got that initial term of negative 4.9, even going back to work you did in 20-1. Now, we can find out what h or what c is here, because we are told that the initial height is 63 meters. So 8h, I should say, equals 63 when time equals 0. So this will allow us to determine our c value for our h function. So that'll be 0 plus 0 plus c. So c equals 63. And our equation for h at t will be negative 4.9 t squared plus 8t plus 63. And you see, it's not a coincidence that, again, the initial term is negative 4.9. You can see that that came from acceleration due to gravity. It's not a coincidence that that middle coefficient is 8. That is the initial velocity of the stone. And it's not a coincidence that the constant is 63. That is the initial height. It is the height at time equals 0. Okay, so those coefficients, they come from somewhere. But the question wants to know, how long will it take for the stone to hit the ground? So for the stone to hit the ground, h at t has to equal 0. The height will be 0 when the stone hits the ground. So 0 will equal negative 4.9 t squared plus 8t plus 63. So basically we want to solve that quadratic. And normally we would try and factor, but if we took out a common factor of negative 4.9, 8 divided by 4.9, you can see it's a pretty long decimal. So that's not going to help us. But that's okay, because we know that we can solve any quadratic by using the quadratic formula. So instead of x equals, it'll be t equals negative b plus and minus the root of b squared minus 4ac all over 2a. So it'll be negative 8 plus and minus the root of 8 squared minus 4 times a, which is negative 4.9, times c, which is positive 63, all over 2a, which will be negative 9.8 when you multiply 2 times negative 4.9. So the value of the discriminant, 8 squared minus 4 times negative 4.9 times 63. The discriminant is 1298.8. And because time can't be negative, we want to use the value here that's going to give us a positive answer, which will be the one if we take negative 8, take away the root of 1298.8, because that is then divided by negative 9.8. So we need the top to be negative as well, so that when we divide, we get a positive answer. So let's take the square root. We'll go negative 8 minus that number, and then divide it by negative 9.8. So it'll take approximately 4.49 seconds for that stone to hit the ground. And so once again, you will not be required to come up with this formula on your own. But as we went through it, I think you can see where it came from. Number 5 says an object travels in a straight line where the velocity is defined by that function. V is measured in meters per second. How far does the object travel in 1 second? So we need to know what the displacement formula is. We know that velocity is ds by dt. So ds by dt will equal 10t minus 2t squared. So to find out what s is, we will take the antiderivative. The power on that first term, the power on t is 1, so when we add 1 to that power, it becomes 2. We divide by that value, minus 2t cubed over 3 plus c. And we know from what we've been doing so far that when you're talking about displacement, movement, when t is 0, s will always be 0, so c is going to be 0 as well. So s at t would be 5t squared minus 2/3 t cubed. And we want to know how far the object travels in 1 second, so we want to know s at 1. That'll be the distance in meters, because the velocity is measured in meters per second, so our units are meters and seconds. So s at 1. So that'll be 5 take away 2/3. 15/3 take away 2/3 is 13/3 meters. Part B then, how far does it travel in 5 seconds? So s at 5 will be 5 times 5 squared minus 2/3 5 cubed. So that'll be 125 minus 5 cubed is 125 times 2 is 250 over 3. So again, we could get a common denominator there of 3. It'll be 375 over 3 minus 250 over 3, which is 125 over 3. Meters. Let me just check all that, but I think that's right. And 25 times 3 for my new numerator is 375 minus 250. Yeah, is 125 over 3. So it's 41 2/3 meters. C says the object is back to its starting point after 7.5 seconds. How far did it travel to get there? So what this means is that the object moves away from its starting point. It's going to have to stop, and then it's going to have to come back. Okay? The thing that you can't assume, though, always is that the velocity is a constant. We don't know that. Okay? We don't know that. So what we want to do, like I said, the object is going to move away from its starting point. It's going to stop, and then it's going to come back. So that object will stop when the velocity is 0. So let's start there. V at t, the velocity, we found to be 10t minus 2t squared. Or we were given that. And again, we want to know where this is 0. So we can solve this by factoring. On the right, there's a common factor of negative 2t to take out, which will give us t minus 5. Our solutions to this would be t equals 0 and 5 seconds. So obviously at time 0, the object hasn't started moving. The second solution to this quadratic is 5, so that means the object started. It took 5 seconds to get to the point where it stopped, and then it came back, and because the total amount of time that it traveled was 7.5 seconds, that means it took 5 seconds to get to the end, stop, but only 2.5 seconds to come back. So again, it moves faster coming back than it did going. Okay? So let's find our distance. So after 7.5 seconds, we're going to have to take the distance that it traveled in 5 seconds, which we know above was 125 over 3. We already calculated that. So it went 125 over 3 meters out, and then the same distance to come back. It just did it quicker. So it'll be 125 meters, 250 over 3. So it just so happens, this question was designed like that, so we're using our answer for part B to help us out here. If we didn't already know how far the object traveled in 5 seconds, we'd have to go back and figure that out, but we already did it. So there's our answer for how far it would travel to get there. And again, so happens that it went a lot faster coming back than it did going. All right, so what you can work on page 415, questions 1 through 6. So there's a couple things I want to make note of here. For number 5, it's one of those proof ones. You're going to use V equals A times T, and you're also going to use the fact that S equals 1/2 AT squared plus C. So those are formulas that we worked with before. And for number 6B, time should be 10 seconds. Okay, so there's a couple things of note for that assignment. Again, I will post the solutions to Google Classroom so that you can check your answers.